Hey guys, welcome to 8.2 day 2. We're still on the law of signs, but for the ambiguous case SSA, or if you write it backwards, it's a bad word, ASS. So you probably remember from geometry that ASS or SSA was not one of the triangle congruences, and it's because there could be no triangle, one triangle, or two triangles when you have the ASS given. So one angle and then two sides that are not connecting to that angle. So you feel free to look at this, but I'm just going to kind of show you how it works. But if this is helpful for you, you can look at that. Okay, so let's figure out if you're given an angle and two sides that are not side angle side, how can you tell if there are one triangle, two triangles, or no triangle at all? Okay, aside from the fact that it actually says in the problem. Okay, so let's see what happens here. So let's start by finding a pair of an angle and a side that we have both of. For example, we have this angle here and its opposite side. So we definitely want to use those two when we set up our first proportion. So it's going to be sine of 40 over 3. And now, which other set do we want to use? Well, we can't use the c's because we don't have either of them. So it looks like we're going to have to use the b's. So let's just set up law of sines here. Sine of angle B over side B, which is 2. And then we're going to cross multiply and try to find angle B. All right, so if you cross multiply, it's going to be, I'll just do it down here. It's going to be 2 times sine of 40 equals 3 times sine of B. And then to get sine of B alone, you would just divide both sides by 3. And then, if you're finding an angle, don't forget you're going to do inverse sine. Okay, so in the end, to get angle B, we're going to do inverse sine of this ratio because we're finding an angle. All right, so let's type that in. So it's going to be inverse sine of 2 times sine of 40 all over 3. And that gives us 25.4 degrees. Okay, so angle B equals 25.4 degrees. Okay, great. But now, so that means we have at least one triangle. But now the question is, what if the triangle looks different and angle B could also be something else? It could be a second triangle. So what you do is you subtract 180 minus this first angle that you found. So 180 minus 25.4. And that gives us 100, let me write this out. That gives us that angle B could also maybe be 154.6 if it was a different type of triangle. But then you got to see, could it be 154.6? And you would say no, because 154.6 plus 40 is already past the 180 degrees that a triangle is allowed to have, and we still need angle C. So if that isn't possible, then we know that we only have one triangle. Okay, so whenever you find the second angle, just do 180 minus it to see if that could potentially be the angle for a second triangle. Okay, but it's not. So we only have to focus on one triangle. Okay, so now we need to find angle C and side C. So angle C is going to be really easy. For angle C, we'll just take 180 minus the 40 and the 25.4 that we have, and that says angle C is 114.6. And now all that's left is side C. So let's set that up. We'll do law of sines again. I'm going to stick with the original ratio that we were given. sine of 40 over 3, and now I'm going to throw in my c's. Sine of 114.6 over side c. And then you guys will cross multiply and find side c. Okay, so without writing it all out this time, you would be doing 3 times sine of 114.6, and then you would actually be dividing it by sine of 40. And side c would be about 4.2. And that's it. Okay, so that was a situation where side-side angle, we only had one triangle. All right, let's move on to the next one here. Okay, so this one, let's see, let's say we were given this here. So this is ASS. Oh, sorry, you can't even see. This is ASS. But if you think about it, what if the 6 was over here? Then that would be a totally different triangle with the same givens. Okay, so I know we can kind of tell by the way the picture's drawn that we're going to have 2 solutions, but let me show you for real how to know. Okay, so let's set up our first ratio here with law of sines. We have the 35 and the 6 being opposite each other. So let's definitely use those. And actually, why don't we name these? A is 6, B is 8, and angle A is 35. That means this is angle B and this is angle C, and this is our second angle B. Okay, so that could be like B1 and B2. Okay, so let's start by finding angle B1. Let's see if we want to find that first. So we'll do law of sines with the A's. Sine 35 over 6 equals sine of B1 over 8. All right, and we'll cross multiply and try to find angle B1. All right, so again, I don't think I have to write it all out for you guys. You're going to cross multiply. So sine of 35 times 8, but then you need to divide by 6, but then since you're finding an angle, we're going to do inverse sine of that ratio. Okay, so no matter how you do it, angle B1 is, we can call that 49.9 degrees. Okay, so now let's see if it was possible to get another triangle. So remember, let's take 180 minus that, and let's see if that's possible. So 180 minus 49.9 is 130.1. Could that work as a possible second triangle? And you would say, okay, well, 130 plus 35 is still less than 180. So that's, yes, it could be. So that means that for our second triangle, this is going to be the measure of angle B2. And now we'll just kind of draw a line here, and we're going to be able to find everything for both triangles. Okay, so for triangle 1, and that's this blue triangle here, angle B1 is 49.9. Let's find angle C1. So that's going to be 180 minus the 35 and the 49.9. Okay, so that's going to be 95.1 degrees. And then let's do law of sines again then to find side C. Well, C1, if you want to call it that. Okay, so another law of sines, let's use our initial ratio again. Sine 35 over 6 equals, and then for C, we'll do sine of 95.1 over side C. And then we can just cross multiply to solve. All right, so if you cross multiply, it's going to be 6 times sine of 95.1 divided by sine of 35. And no inverse on this one because we're not finding an angle, we're finding a side. So side C would be 10.4. Okay, cool. And now let's go find angle. Let's look into the second triangle. Okay, so if B2 is 130, and it looks like we have these in the wrong spot. This is really B1 and this is B2, but it doesn't matter because you're just finding them both anyways. Okay, so for B2, if the angle is 130, let's find angle C2. So it's going to be 180 minus the 35 minus the 130.1. So we're going to kind of do the same thing. In this one, angle C2 is 14.9 degrees. And now we just have to find side C2. But again, that was really that triangle. Doesn't matter. So let's do law of sines again. Let's use our original ratio. Sine 35 over 6 equals, and we'll do sine of the 14.9 degrees over the new side C. So we'll call it C2. All right, so if you guys cross multiply, we get 6 times sine of 14.9 divided by sine of 35 again. And this time, side C is going to be 2.7. Okay, so you'll notice that triangle 1 was actually this triangle, the big one, and triangle 2 was actually the small triangle. But in the end, it doesn't matter how you write it. Okay, nice job, guys. Why don't we save number 3 for class just as a warm-up to make sure law of sines makes sense. Thanks for watching.